The next two examples are not in your book, but I did want to go over this concept with you guys. So let's say if we have this question, we're given two powers and they want us to write as a radical. So the first thing we would do is we would multiply these using our exponent laws, where the bases are the same, the exponents add. So the challenge here is because we have fraction addition. We're going to do this on the side. Lucky for us, the denominators are the same, so the numerators will simply combine. So this will become x to the power of 3 over 5. And now we can write that as a radical, where x becomes a radicand, 5 becomes the index, and the 3 will become the exponent. Or if you want to write that as fifth root of x and then everything to the power of 3. Remember, you can express this back as a power. So if you want to go back as a power, what do you need to do? You need to watch out again. The base will still be the base. X is the base and the exponent. Remember, the 5 came from as a denominator, so you put it back as a denominator. And this 3 outside is your numerator. So we should know how to switch it back and forth. It comes in handy, especially an example like this, where they give us two radicals and they want us to express as a single entire radical. Now, if you remember from your radical rules, you can't multiply these because the index are not the same. So we can only multiply them if our index are the same. So a fix to that is to first express these as a power. So the 2 here, invisible 2, will become my denominator, and this will become my numerator here, multiplied with, this is your denominator, 5, and to the power of 2. So we're going to do the same thing. We're going to use our exponent laws and say we should be able to add these. So I'm just going to do that on the side here. Now, because these are two different denominators, they both need to become a common denominator, and they both can become 10. So we change them into 10, so here becomes 15 over 10, and this needs to be multiplied by 2 to become 10, so 4 over 10. So when we combine the numerators, it will become 19 over 10. Big number, but it doesn't make a difference. We're now going to write it as a radical. So x becomes a radicand, denominator becomes the index, which is 10, and then 19 becomes our exponent power. So, or if you want to put that 19 outside, same thing. Okay, so this was an application of things that we have learned earlier and put together with this one. So I will see you in class, and then we will go over that last example, number 5, together in class.